This topic continues with factoring, but we're going to be talking about cubes instead of squared. So this is not a review. This is a new topic to this course. If you look at the top of your notes, you'll see a chart that's been started for you. And just to familiarize you with the perfect cubes, I've got the numbers 1 through 8, and we're going to fill in the perfect cubes. So 1 cubed, or 1 times 1 times 1, is 1. 2 cubed, or 2 times 2 times 2, is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. And 8 cubed is 512. It's not like you need to memorize those, but you do need to be somewhat familiar with them when you see them, realizing, oh, those are perfect cube numbers. So let's look at how you factor a difference of 2 cubes or a sum of 2 cubes. Unlike when we did other types of factoring, there's not a process involved here really. It's just more of what I call a recipe. So the recipe for the difference of 2 cubes is you're going to make a short parentheses and then a long parentheses. And we're going to look at what got cubed. What got cubed here is x. What got cubed here is y. So we're going to call the x our first and the y is our second. So we say the first, the second, I'll worry about signs at the end. The first one gets squared, multiply the 2 together, and then square the second one. Now to fill in the signs, we're going to use a little acronym called SOAP, and it stands for same, opposite, always positive. Excuse me. Same means the same as what you started with. So same, opposite of negative, always positive. Same, opposite, always positive. So let's try a few. That's the recipe for factoring difference of 2 cubes. So here, what got cubed in example 1a is an m and a 2. So when we write our short parentheses and then our long, we're going to have first, second. First one squared, multiply them together, second one squared. Now we do our signs, same, opposite, always positive. And that is the factoring or the factorization of m cubed minus 8. Let's look at example 1b. What got cubed here is 3x. What got cubed here is 2y. So again, your short parentheses and then your long. And we say first, second, first one squared, so that means 3x squared. So both the 3 gets squared and the x. So first one squared, multiply them together, second one squared, same, opposite, always positive. Same recipe every time. What got cubed here is 10k. What got cubed here is 3n. So we make our parentheses and we say first, second, first one squared, multiply them together, second one squared. Same, opposite, always positive. Exact same recipe. It's the same thing for the sum of cubes. It's going to be same kind of parentheses, x got cubed, y got cubed, so it's first, second, first one squared, multiply them together, xy, and second one squared. Where it's different is when you do the acronym SOAP, because this time the S for same is a positive, so same, opposite, always positive. So let's try some sums. This is an R and a 3 that got cubed. So we're going to go first, second, first one squared, multiplied together, second one squared. Same, opposite, always positive. Notice it's the same little recipe that I'm using. It's just that the S and the O, same and opposite, are different when you start out with a plus than a minus. All right, here, what got cubed is a 3z. What got cubed here is a 5. So we have first, second, first one squared, multiplied together, second one squared, same, opposite, always positive. A little bit bigger here, and this one has a couple tricky things about it. What got cubed here is a 5t. That's not tricky, but this is. What got cubed here is a 6s squared. Think about it. Let me go over here in the margin. If I take 6s squared and I cube that, that's going to give me 6 cubed, which is 216, and then I multiply these, s to the 6th. So now that we have that, we do the same thing. First, second, first one squared, multiply them together, and I didn't leave space. Second one, let's leave space. Second one squared, 36s to the 4th, because we're squaring s squared. So we go same, opposite, always positive. Sorry about the scribbles. So that one you had to be careful with. This one, 3 is not a perfect cube. Neither is 192. It doesn't come up. It would be between those, and it doesn't come up on our list. So I'm thinking I must have to factor out a GCF, which often happens in factoring. You first have to factor out a GCF. So my GCF here is 3, and I'm going to be left with x cubed plus, divide 3 into 192, and you're going to get 64. Now, oops, that's supposed to be a cubed. These are perfect cubes. What got cubed here is x. What got cubed here is 4. So we're going to start this the exact same way. First, second, first one squared, multiplied together, second one squared, same, opposite, always positive, but that GCF 3 is part of my final factored answer because I had to factor it out first. So let's summarize some conclusions down here at the bottom of your notes. If you have difference of two squares, x squared minus y squared, it will always be x plus y, x minus y. If you have a perfect squared trinomial, x squared plus 2 or double of the xy's and then a y squared, that means x plus y times x plus y, or x plus y squared. Same thing with a perfect squared trinomial of x squared minus 2xy. That's going to be x minus y squared. This one I want you to pay special attention to. If you have the sum of two squares, it is prime. It cannot be done. Difference of two squares, yes. Sum of two squares, no. That's different than it is with cubes. I can do the difference or the sum with perfect cubes. So with cubes, this is that recipe one that we just did. It's going to be first, second, first one squared, multiplied together, second one squared, same, opposite, always positive. This next one, sum of cubes, is going to be the exact same thing, but it's going to go same, opposite, always positive. If you know that you can't factor or you feel like you need some extra work on factoring, you need to practice in the book, come see me, go to your local tutoring center. The rest of this course hinges on you being able to factor, so it's very, very important that you can do that.